Okay, so this question says e to the power x into x plus 1 is equals to 1. E to the power y, sorry, this is e to the power y. So e to the power y into x plus 1 is equals to 1. This is our function. And what do we have to prove? We have to prove that this d square y by dx square is equals to dy by dx whole square. So it's actually straightforward. What you have to do is you have to apply the uh, you can do it by separating the y terms on one side and x terms on one side. That is one way of doing it. Other way of doing it is uh, you can actually start differentiating them just like any other implicit function. So this thing can be taken as e to the power y as one function and x plus 1 as another function. So this is uv format, and differentiation of uv is u dash v plus uv dash. The same thing we are going to do here. First, differentiate the first function, that is e to the power y with respect to x. So that will become e to the power y, e to the power y into dy by dx into x plus 1, right? And plus, so this entire thing is u dash, and this is your v. So u dash into v. Next, what do we have to do? We have to write u as it is, so e to the power y as it is, into differentiation of x plus 1. So differentiation of x plus 1 will be just 1, right? And this should be equal to 0, right? Because that is what we have here. Correct. So this is the first, that the RHS is actually 1. So differentiation of 1 will be 0. This is the first expression, and that is the differentiation after first stage. Now in this, we already have now, or we can say that this is e to the power y into x plus 1. If you see that this part, then this says e to the power y into x plus 1 is 1, and we have this here, e to the power y into x plus 1. So I can substitute that as 1, so it will become just dy by dx is equals to minus e to the power y, right? And if it is like this, now if I differentiate it second time, so it will be d square y by dx square is equal to minus, take minus out, e to the power y as it is, and dy by dx. Correct. Now, so this is our, I mean, the expression after second time differentiation. Now see this carefully. Here you have minus e to the power y. And what is minus e to the power y? That is actually equals to dy by dx. And here also we have this minus e to the power y. So that means now this I can say that this d square y by dx square is equal to, instead of minus e to the power y, I write dy by dx, and next anyways we have dy by dx. So this gives me what? This gives us d square y by dx square is equals to dy by dx whole square. That's what we had to prove. So that was the 16th question. If you have if you had come across some other doubt, let me know. Otherwise, we'll move to the next topic, that is mean value theorem. Okay, so next topic is mean value theorem. This is also called, in short, MVT. So what we are going to study here is some property about differentiation, right? So there are actually two theorems here. One is Rolle's theorem, and another is mean value theorem. The second theorem is mean value theorem. So what exactly is the Rolle's theorem? First we'll see that, and then we'll move to the next part. So before going into the definition or the statement of this, let us first understand it by a concept. So the theorem says that if a function is continuous in, you can say, between 2 points A and B, and it is differentiable in this particular range or domain, and we have this situation such that f of A is equals to f of B, but A and B are not same. So there must be a point where f dash C, or there must be a point C between A and B, where the f dash C will be equals to 0. So what does it mean? Suppose we have this function, any function which is at 2 points A and B, they are having same value. The function is having same value. That means it has to be like this, right? So that at both A and B, the functions are having same value. This is B and this is A. So this value, or say this value, is corresponding to f of B, and this, I mean, when this graph is of function f of x. So even this point will be f of A, and as you can see here, both are same. So both f of A and f of B are same. So these two functions values are same at A and B, and the function is f of x. So that is possible if it is a continuous graph. So that is possible only in two conditions. Either the graph is like this, such that at A and B they have the same value. So this is A and this is B. So graph, if it is decreasing and then increasing, it will have to go down and come back. Then only it will be same value again. And if it is different type of function, say like this, that is just opposite function, first increases and then decreases, then the graph will have to return from the top. So in this case, it is returning from the bottom, and in the second case, it is returning from the top. But it has to return. And obviously this point where it is returning, right, there, suppose if that point is corresponding to C, suppose this point corresponds to C, where the return starts. So here at C, you can see the tangent will be like this. This green line is the tangent to the curve. This green line is the tangent to the curve. And you can see that if it is returning, so tangent will touch the curve at only one point. And that's why at that point, this tangent will be parallel to x-axis. It will have to be parallel to x-axis. And when we have started differentiation in 11th class, we have also seen what is the purpose of studying differentiation. In that, we have also seen geometrical interpretation of differentiation, and which says that the slope of the tangent is equal to differentiation. So the tangent here is this. What is its slope? Obviously, its slope is 0. Why? Because this is parallel to x-axis. So in both the cases, if a function will give you two values for the same, for different values of x, that is possible only if the function is returning to that value either by going up and coming down, or by going down and then returning and coming back to the top, right? So it has to return. So the point where it returns, at that point the tangent will be parallel to x-axis. And if it is parallel to x-axis, its slope is 0. And what do we know about slope and tangent? That and differentiation, that dy by dx is equals to slope of tangent. And what is that slope? Slope is 0. So that means this mean value theorem can be summarized as, when we have a function f which is defined in closed interval, say a to b, to any real numbers. Suppose this is the function and it is continuous in that domain, and differentiable. That means you can find its differentiation. So it is both continuous as well as differentiable in the same interval a to b. But when we say continuous, we are talking about we are including a and b. When we say differentiable, we are excluding a and b. But this is the function defined such that there are 2 points for which 2 points a and b, for which f of a is equals to f of b, where a and b are obviously some real numbers, right? And in that case, there must exist a point C. There must exist a point C in that interval a comma b, such that f dash c will be equal to 0. So this is what this Rolle's theorem means, right? So that is what is Rolle's theorem is all about. I hope you understood this point. This is very important. That is what mean value theorem, the Rolle's theorem is. Now let us, and this is minimum 1 point. I mean, there can be even more than one. So when can be there more than one? Suppose your function is like this. Suppose the function is like this. Now, obviously, if I draw this x-axis, right, or a line parallel to x-axis, say this. So this is a line which is parallel to x-axis, as you can see, and because it is parallel to x-axis, 1 minute. This is not x-axis. This is a line which is parallel to x-axis. So if a line is parallel to x-axis, what will happen? The value of y at that particular line will be constant. Say this is equal to some uh, p. So that, and suppose these are the points which are corresponding to different values of x. So say this is x is equals to a, this is x is equals to b, or this is x equals to c, and this is x is equals to d. So there are 4 points. So what do we see here is there are exactly 4 points for which we can say that f of a is equals to f of b is equals to f of c is equals to f of d. So there are 4 such points. And in order to do that, if a and b are same, then between a and b, the curve has to take a turn. So you can see here, there is a turn here. Same way, there has to be a turn here and there has to be a turn here. So there are exactly 3 points for which you will get the tangent parallel to x-axis. And if these tangents are parallel to x-axis, that means at that particular point, the differentiation or slope is 0. That means the differentiation is also 0. Right? So there will be 3 such points here in this case. That is, say this x is equals to e, then x is equals to f, and for this x is equals to say g. So there are these 3 points e, f, and g for which we can say that f dash of e is equals to f dash of f, which is little confusing. You should not take the same letter, is equals to f dash of g is equal to 0. So there are 3 such points. So there can be multiple points. So if it is only a and d, between a and d, as you can see here, there are 3 points. Between a and c, there are 2 points. Between b and d, there are 2 points. Between b and c, there is 1 point. And between a and b, there is 1 point. So minimum there has to be 1 point when we have two values of x for which the value of function are same, right? This is called Rolle's theorem. Now our next theorem is actually the mean value theorem. So let us see that as well. Okay, now the actual mean value theorem. So what is that? Now this is same, or this is actually based on the Rolle's theorem itself. And it simply says that if you have, say, f, which is defined in a closed interval, say from a to b, and defined to, I mean, the range is all real numbers. And if it is a continuous function, again, same thing, continuous in a comma b and differentiable in open interval a comma b, then there must be a point c. There must be a point c which belongs to this range a comma b, that is other than a and b. In between a and b there is a point c such that f dash C is equal to f of b minus f of a divided by b minus a. This is the important part of mean value theorem, right? This is what mean value theorem is. So mostly in this exercise, we will have to verify mean value theorem or Rolle's theorem for the given function in a given domain, right? So even this particular theorem, right, it is very easy to understand. So let's see how we can, or what is the logic or the proof behind this. So it's again very simple. Suppose you have a function f of x which looks like this, right? So this is a function. Say this is your f of x. Now there are just 2 points. We are not saying that f of a is equals to f of b. Otherwise, what will happen? Fb minus fa will be 0. If f of a and f of b are same, then fb minus fa will be 0 and f dash c will be equals to 0, which we already know. That is Rolle's theorem. So what we are going to do here is we are going to discuss the mean value theorem. So in this, you have this graph of f of x, and there are 2 points, or this point say belongs to x is equals to a, right? Suppose this is your x-axis. So this is your point x is equals to a. Same way, suppose this is the point x is equal to b. So this point will be what? It will be x coordinate will be b and y coordinate will be f of b. And same way, this point will be a comma f of a. So these are the 2 points. What we are saying here is there will be a point C where the differentiation of that point or derivative at that point, say suppose we are talking, or say we join this a and b, right? So we joined this point, these two endpoints called a and b. So what happens now is this is the y difference, that is f of b minus f of a is actually equal to what? Is actually equal to this, somewhere over here. This will be f of b minus f of a, right? And then divided by this b minus a. This is what? This length is b minus a. So this divided by b minus a is what? This is your average rate of change. Differentiation is what? Rate of change. And this is this particular fraction which we have seen here. It takes into consideration only the endpoints. So that's why this is nothing but average rate of change, right? At any point C. So if you have got an average and this is a continuous function, so obviously there will be a point where the rate of change, the instantaneous rate of change, will be equal to the average rate of change. It has to be, right? And that's what, that there will be a point, or there, from here to here you can obviously draw a tangent. I mean, now we think about this in terms of geometry. So you can always draw a tangent parallel to this line, parallel to fb minus fa. It is possible to draw a tangent, and this is that tangent. which is parallel to the line f, I mean which starts from this to this. Say suppose this point is P and this point is Q. So this tangent, the green tangent, is actually parallel to PQ. So if these two lines are parallel, so from the figure you can say that, right, it is bound to happen. So if the line is parallel, if the tangent is parallel to the line PQ, that means their slope will be also same. So if their slope will be same, that means these two lines are parallel, slope has to be same. And what will be the slope of this line PQ? This is the slope, but this slope gives us average rate of change. And same way, slope here, what we'll have to do is we'll have to find this point C, which will be somewhere between x is equals to a and b, but it may not be exactly midway. That is not the condition, or that is not something which you can say for sure that C will be exactly in between A and B, but C will be there. In between A and B, there will be a C for which you can, if you draw a tangent, such that at that particular time, the tangent will be parallel to the line PQ. And if that is the case, the both will have same tangent or same slope. So that means this is your slope of line PQ. Same way, the slope of this line, green line at C will be what? That will be nothing but f dash C. And these two have to be equal. So we say that this f dash C is equal to f of B minus f of A divided by B minus A. This is what mean value theorem is all about. So the questions which we'll solve now in this exercise, that will be mainly the problems where we'll have to verify the Rolle's theorem or MVT theorem for those. The second type of question will be where it will be given that it satisfies the theorem, either Rolle's theorem or mean value theorem, and due to that, or keeping that in mind, we'll have to find something else or some unknowns in a particular question. So there are these two type of questions here. Now let's solve these questions one by one to properly understand these two theorem. So this is the last exercise or the last concept of this chapter. After that, your miscellaneous examples and problems start. So that will actually cover or finish due to, I mean, if we do this, we will be finishing our differentiation chapter, but there will be more problems to solve, which we'll try to solve from books like R.D. Sharma or some other text, reference books. So let's see this problem. First, you have to verify Rolle's theorem for the function y is equals to x square plus 2. And the range or the domain is given as a is equals to minus 2 and b is equals to plus 2. So actually this is clear from the graph, but from the function itself, if your coordinate geometry in 11th class is good, you can easily solve this problem even without doing calculus. But because we have to right now verify Rolle's theorem, so let's try to solve it using or solve it like that. So what is this? What does Rolle's theorem say? That if f of a is equals to f of b. So first check whether that is correct or not. So f of a is equals to f of minus 2 is equals to minus 2 square plus 2, which is actually equals to 6. Same way, f of b is equals to f of 2, even that is equals to 2 square plus 2, which is equals to 6. So we have this. So f of a is equals to f of a. Now what do we have to do? We have to prove that there is a point between this plus 2 and minus 2 at which the differentiation of function will be 0. So in order to do that, let's first find what is y dash. So y dash is just 2x. And when will this y dash will be equals to 0? So this will be equals to 0 means 2x will be equals to 0. That means x will be equals to 0. And what do we see here now? So the point where the differentiation is 0, there is a point where differentiation is 0. And where exactly is that point? So that point 0 is actually between your minus 2 and 2. So that means we have f dash c equals to 0 such that c lies between the two extremes, that is a equals to minus 2 and b is equals to plus 2. Right. So that was about Rolle's theorem. That's how you have to prove or verify Rolle's theorem. Let's move to the next part where we have to do the same thing for mean value theorem. So here we have to verify mean value theorem for the function y is equals to x square and interval is 2 comma 4. Now here see, this is not what Rolle's theorem is. This is our MVT. So in MVT, the two extremes, right, 2 and 4 may not give you the same value for function. So f of 2 will be equals to 2 square. F of 4 will be equals to 4 square. So one is 4, another is 16. They are not equal, right? But here what do we have to do? We have to verify mean value theorem. For that, what we have done or what we have to do is that we have to find a point C such that f dash C will be equal to f of B minus f of A divided by B minus A, right? So what is B? B is 4. What is A? A is 2. So let us see if we are able to find that or not. So what is y dash? Y dash is 2x. Now let's see the interval. So there we have to do fb, that is 4 square minus 2 square divided by 4 minus 2. So what will I get here? I'll get 16 minus 4 divided by 2, that is equals to 6. Right? So we have got this point or this value is equals to 6. So this is the, you can say, the average rate of change, fb minus fa divided by b minus a. That's what we have done here. So this is just application of this formula. Now we have to verify Rolle's theorem. So this is on the second part of this formula, not the first part. The first part says that there will be a point C between A and B for which this expression or this will be the rate of change. So we say, okay, let's try that. So there is a point f dash C such that that is equals to or just f dash C, so that is equals to C, sorry, 6, and this is actually our f dash C. So that means this 2x is equals to 6 or x is equals to 3, right? X, you say it x or C, doesn't matter. So from this I can say that this C has to be 3, and 3 actually is in the same range. That is interval 2 to 4. So it lies in that interval 2 to 4. So there is a point between 2 and 4 where the this rate is equals to 6, and that is 0.3, right? So that's all about this mean value theorem and the Rawls theorem. So in the next class, we'll discuss the miscellaneous problems. I'll send you the miscellaneous problem today. You go through them, try to solve it, just like Roshna asked some doubt today. Send me your doubts in advance if you have any doubts.